This is question 5 from the 2022 reserve paper for A2 pure maths from CCEA. Let's take a wee look. The points of intersection of the curves y equals cosec squared 3x and y equals x squared plus 1 can be found by solving this equation. Obviously, you put the two equations equal to each other and then take everything to one side. Show that this equation has a root between 0.3 and 0.5. Well, what we're going to do is we're going to sub in 0.3 into this. We're going to sub in 0.5 into this, and the sign should change. So let's see. Now 0.3, make sure your calculator here is in radians to work this one out. But we're going to first of all let f of x equal this function here, cosec squared 3x minus x squared minus 1. And then we're going to find f of 0.3. If you put that into your calculator, so cosec is obviously going to be 1 over sine. You're going to do 1 over sine squared 3x. You're going to times the 0.3 by 3 and substitute it in, but you end up with 0.53972 or whatever. We don't need it kind of quite so accurate. We're going to do the same then for 0.5. Again, we're substituting the same thing in, and we get minus 0.24497. That's the information we want. We want one to be positive and one to be negative. And because one's positive, one's negative, it must have crossed then the x-axis. Because it's a continuous function, then there must be a root in between those two. And we need to write that then as a wee sentence to get our final mark. So, since there is a change of sign in f of x between 0.3 and 0.5, and f of x is continuous in this range, then there is a root between 0.3 and 0.5. Never written so much in a A-level pure paper before. So that's part 1. On then to part 2, it is known that there is only one root, alpha, in the interval between 0.3 and 0.5 by taking 0.3 as a first approximation using Newton-Raphson method once to find a better approximation then to alpha. So we're going to have our same then f of x. Just lost my page. F of x equals cosec squared 3x minus x squared minus 1. And then f dash of x, we need to think about this here. So we need to kind of think about differentiating this bit here. This bit here then is going to be fine to differentiate, but we have that. So how do we differentiate this? I might actually write it just very slightly differently. So I normally do these like this. Cosec 3x whole squared. So it's going to be, you bring the 2 to the front, and then you take away 1 from the power here, the 3x. So that's kind of down then to the 1, and then you multiply by the bracket differentiated. Now, whenever you differentiate cosec x, you get minus cosec x cot x, but the fact that it's a 3 means then a 3 then kind of comes to the front. So it's going to be times by minus 3 cosec 3x cot 3x. So there's a wee bit going on there. I hope you follow that okay. I like to write it like that before. That's not a differentiated, but that's just the way I kind of do it. I sort of take the 2 out as if it's in the bracket. 2 goes to the front, take away 1 from the power. So I have that, and then multiply by the bracket differentiated, and it gives you then that. This bit then is nice and easy. That's going to be the minus 2x. So we'd want to tidy that up very slightly. 2 cosec 3x times minus 3 cosec 3x. So that's going to be minus 6 cosec squared 3x cot 3x minus 2x. Newton-Raphson then defined x1. We only need to use this once. x0, take away f of x0 all over f dash of x0. So I'm substituting this in, and I'm taking the first approximation to be 0.3. I'm effectively substituting in 0.3 into this and 0.3 into this. So my x1 value, then as I said, it's going to be 0.3. Take away, let me see, where's my f of x? This is it up here. So it's going to be cos x squared, so 3x, then it's going to be 0.9 minus 0.3 squared, take away 1. The bottom line then, minus 6 cos x squared, 0.9 cot 0.9 minus 2 0.3. So a fair bit going on there. If you want to type that all into your calculator, and if you're lucky enough, you'll come out with 0.365. Remember, in this scenario we are in radians, so make sure you have it for there. Give an approximation. I'm going to 3 significant figures there. That's generally what we have.